Hi guys, in this video what we're going to do is we're going to look at what's called the second general equation of the circle, and it's much more useful than the first general equation that we looked at in the previous videos. Okay, so the second general equation of the circle, the standard form is given by x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Okay, the main thing to remember with this is it has to be x squared plus y squared. You cannot have any coefficients in front of the x squared or y squared. If you have to divide everything by a certain number in order to get that, that's fine, but it has to be of the form x squared plus y squared plus some x's plus some y's plus c is equal to 0. Now this represents a circle with the centre minus g minus f, so you can see here the circle. The centre is given by minus g minus f, and the radius is given by g squared plus f squared minus c, all square rooted. So let's see in practice how we can actually use this. So we've been asked to find the centre and the radius of the equation of the circle given with x squared plus y squared minus 4x plus 8y minus 5 is equal to 0. So all we do, you can see here, the x squared plus y squared, we don't do anything with that. We have a look at the x's, and to find the centre, we take a look at the x's and we look at the y's, and we halve each of the coefficients in front and change the sign. So this minus 4 halved is minus 2, change the sign, is 2. This 8 halved is 4, change the sign, minus 4. So the centre now, which is given by minus g minus f, is 2 minus 4. For the radius, we throw it through the formula, g squared plus f squared minus c, so g squared, which is 2, plus f squared, which is minus 4 all squared. And you can see here minus c, just be careful with the signs. You can quite often get a minus minus here, guys. So minus 5 becomes equal to positive 5, and if you work that out, it comes out to be the square root of 25, which is equal to 5. So let's have a look at a few examples here, see if we can work out the centre and radius of each of the following circles. Remember, if you're not sure, the radius is given by f squared plus g squared minus c. Okay, so for the first one, have a look, x squared plus y squared minus 6x plus 8y minus 11 is equal to 0. So the centre. So minus 6, so have a look at the x. Minus 6, halve it, gives you to minus 3. Change the sign, gives you to 3. Have a look at the next one, which is 8. Halve it, gives you to 4. Change the sign, gets you to minus 4. So there's the centre all done. My radius is equal to f squared, which is 3 squared, plus g squared, which is minus 4 all squared, minus 11, so that's going to be positive 11 in a second. Work it out, we get r is equal to 9 plus 16 plus 11, so 9 plus 16 plus 11. 9 plus 16 is 25, plus 11 is 36, so r is equal to root 36, which implies that r is equal to 6. So this first one has centre of 3 minus 4 and a radius of 6. Let's look at the second one. So the second one is x squared plus y squared minus 8x minus 1 is equal to 0. So let's have a look at the centre. So we're looking for the x's. So you can see here, we've got minus 8, so we're going to halve it and then change the sign. So that's going to be equal to 4. So let's just write centre. We have 4. And now look at the y. Well, we don't have any y's, so that means that we have 0 y's, and 0 divided by 2 and changing the sign, it's not going to make any difference, it's still going to be 0. And now we're going to work out the radius. So the radius here is 4 squared plus 0 squared, minus 1 again, so we've got that double negative, so be careful of that. R is equal to 16 plus 1, which is 17, so r is equal to root 17 in this case, and we can't simplify it. Let's have a look at I. We've got 2x squared plus 2y squared plus 8x plus 2y minus 4 is equal to 0. Now, we said it has to be of the form x squared plus y squared plus some x's plus some y's minus or plus or minus some constant is equal to 0. And you can see this isn't the case because we've got the 2x squared and the 2y squared here. So what we're going to do is we're going to divide everything by 2. Don't forget, this is still an equation. It's an equation of a circle, so as long as we do the same thing to both sides, that's still valid. So if we divide the left-hand side and the right-hand side by 2, we get x squared plus y squared plus 4x plus y minus 2 is equal to 0. And we're just going to run through exactly what we've done before. So we get the centre. Okay, what we're going to do is we're going to look at the x values. Here, we're going to divide by 2, which is 2, change the sign, which now becomes minus 2. Okay, next thing we do is look at the y value. Y is equal to 1, halve it, which means it goes to a half, change the sign, so it's 2 minus 2 minus a half. Okay, the range is going to be a little bit more of a pain to work out because of the fraction, but shouldn't be too difficult. We've got r is equal to minus 2 all squared plus minus a half all squared, and we've got minus 2 here. Remember, quite often you're going to get the idea that you're going to get that double negative, so let's work that out. So we've got r is equal to minus 2 all squared, which is 4, plus minus a half all squared, which is a quarter, and then what we've got is minus 2, which is plus 2. Okay, calculate that from there. You've got 6 plus a quarter. 6 plus a quarter, so r is equal to 6 plus a quarter. Square rooted, just going to put it to the top here, guys. So 6 plus a quarter, and that's equal to, if you put that into your calculator, you're going to get r is equal to the square root of 25 over 4. That's quite handy. They're both going to work out as they're both perfect squares. So r is equal to the square root of 25, which is 5, over the square root of 4, which is 2. And that means that the radius for this particular one is 5 over 2, with the centre being minus 2 minus a half. Just be aware that this second one here, where you have the whole idea of the minus 8x and there's no y's, a lot of people make the mistake of just getting this number here and halving it and using it for the centre. If it's not got a y here or a y value, and there are no y values, therefore it's 0. Okay, a lot of the time what we're going to do is, when we have a circle problem, we're going to use what's called the GFC method. And that's why I said this is so important that we use this second equation of the circle, the general form, because this is where we can actually start using this method. So there's a few ones here that we can use, or a few techniques that we have. And the first one is, if we're given a point on the circle, then all we do is we stick that particular x and y coordinate into this equation here. And what will happen then is we'll end up with an equation in terms of g, f and c. So, for example, if I was told that the point 2, 3 belongs to the circle, then we can write, there's my x, so x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And when we simplify this, what will happen is you'll see that we're going to end up with an equation in terms of g, f and c. If we're told that the centre lies on a particular line, then I'll show you what that means. So suppose we have that there is your circle, there is the line, and you can see the centre here lies on that particular line, and I'll put some numbers in here. I'll use the example they have there, which is x minus 3y is equal to 4. Then we know, because the standard definition says that the centre of a circle of, if we're going to use this equation, then this must be minus g minus f. Okay, so that now means that we know it's on this equation of the line, which means that we know that the x value is minus g when the y value is minus f. So that now means I can say that minus g minus 3 lots of minus f is equal to 4. So that came from this. So where I see an x, I can put minus g in because it's on the line. So my x value is minus g when my f value is minus, my y value is minus f, sorry. So minus g minus 3 by minus f, tidy it up, and you get minus g plus 3f is equal to 4. And you can see what I have now is I have an equation in terms of g and f. And that's pretty much explaining what's happening in this line here. Now, for c, when it says the x-axis or the y-axis is a tangent, then we can show that c is equal to g squared and c is equal to f squared. So I'll go through the x-axis as a tangent, and it works exactly the same for the y-axis, but it's just a different letter. So if we have a look at the tangent here, you can see that if the x-axis is a tangent, then if we're looking at a circle with minus g minus f, then because this is a tangent, it means that we're not going anywhere in the y direction. So my y coordinate is going to be 0. And you can see here that this is going to be minus g because the tangent has to make a right angle. That means that I'm going to get my formula. So I have my x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. But I know for this particular one that my y value is going to be equal to 0 and my x value is going to be equal to minus g. So I'm just going to substitute that into this and see what happens. So I've got minus g all squared plus y squared, which is 0, plus 2 by g by minus g plus 2fy, which is 0, plus c is equal to 0 here. Now, minus g all squared is g squared, and I've got 2 by g by minus g, so that's minus 2g squared plus c is equal to 0. And then if I tidy that up, I get minus g squared plus c is equal to 0, because g squared take away 2g squared is g squared, and I send it across, c is equal to g squared as is stated here. Okay, now what will happen is if I do it the other way around, where I'm working from this axis, instead of c being equal to g squared, c will be equal to f squared. It's exactly the same sort of idea, apart from I put 0 in here and minus f in for the y. Okay, it's the same thing. The last one here, guys, is given the radius. Suppose we're given the radius. Well, we know that g squared plus f squared minus c is equal to the radius. So what we can do is we can just square everything, and that'll get rid of the square root here, and we'll end up with is equal to something on the right hand side here. So for example, if the radius is 5, we can write g squared plus f squared minus c, all square root is equal to 5, square both sides, and we end up with g squared plus f squared minus c is equal to 25. Notice again that this is of the form g, f and c. So normally what we need is we need 3 bits of information to solve these if we're going to do that, because we have 3 different variables. Okay, so let's have a look at an example of this. So you can see example 2, it says a circle of radius length 20, so we can use the radius formula for that. Contains the point minus 1, 3, so it's a point on the circle, which means we can use the general equation of the circle, and its centre lies on the line x plus y is equal to 0, which means that we can use the idea that minus g and minus f are going to be on this line. It says find the equations of the 2 circles to satisfy these conditions. Okay, so a quick diagram of it. So that's what it is. There's your circle. What we have here is it contains the point 1 minus 3, so minus 1, 3, sorry, there it is. Now this x plus y is equal to 0, and we know that this, according to the definition of the circle, is minus g minus f. We also know that the radius is equal to 20, and I'll sort that out in a second, so r is equal to root 20 there. Okay, so first of all, let's work out with the x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And the information here that we can stick in, because we know a point on the circle, which is minus 1, 3, we can stick for our x value in here, we can stick minus 1, and for our y value, we can stick 3. And we're going to end up with an equation with just g's, f's, and c's in it. So let's do that. So x is minus 1 all squared plus y, which is 3 squared, plus 2 by minus 1 by g, plus 2 by f, which is 3 by f there, plus c is equal to 0. Minus 1 squared is just 1 plus 9 minus 2g plus 6f plus c is equal to 0. Tidy everything up. Hopefully you can see that minus 2g plus 6f plus c, I'm going to take the 10 across, is equal to minus 10. And there is my first of the 3 equations that I'm going to need. Okay, the next thing we know, so I'm going to do this one here, the fact that x plus y is equal to 0. So I'm going to look here. Well, my x value is going to be minus g. My y value is minus f, so I'm going to stick minus g in for x and minus f in for y. So let's just do that. X plus y is equal to 0. So I end up with minus g plus minus f is equal to 0, which means that f is equal to minus g. Or g is equal to minus f. It doesn't really make any difference which one you want to use there. For the radius, we know that r is equal to, and it's f squared plus g squared minus c, all square rooted. And we've been told that r is equal to root 20. So we've got root 20 is equal to f squared plus g squared minus c. And if we square both sides, we now know that 20 is equal to f squared plus g squared minus c. And that there is our third equation. So you can see here now I've got three equations that have been boxed. And all we do now is we have to solve this 3 by 3 simultaneous equation. Now, it's quite nice that we know that f is equal to minus g, which means that we can stick or get rid of one of these variables from both of this one, and that should make it easier to solve. So let's stick f is equal to minus g into this equation 1 and this equation 2 and see what we have. So I'm just going to do equation 1 over here. We're going to end up with minus 2g plus 6 times minus g, so it's going to be minus 6g, sorry. So let's go back and change that. Minus 6g plus c is equal to minus 10. So that means now we're going to get minus 8g plus c is equal to minus 10. That's my first equation. For my second one, what you can see is we're going to end up with 20 is equal to, and it's f squared, which is minus g all squared, because we're going to change it in, plus g squared minus c. And hopefully you can see, guys, that that's going to be 20 is equal to, and it's going to be 2g squared, because minus g times minus g is positive g squared, so it's 2g squared minus c. So that there now becomes my two new equations. Hopefully what you can see here is we have a now 2 by 2 simultaneous equation with the two variables of g and c. And also hopefully you've noticed that this one is non-linear, because you can see it's quadratic. We've got the g squares here, and this one is linear. So we need to use our technique to work out a simultaneous equation with linear and non-linear. Remember, in order to do that, we rewrite in terms of one of the variables. C would probably be a good idea in this one, and then what we do is we substitute it into the quadratic one or the non-linear one. So let's do that now. So I'm going to rearrange one. So rearrange equation 1, and I'm going to get c is equal to something. So hopefully you can see if I take the 8g across, I get c is equal to, and it's be minus 10 plus 8g, so 8g minus 10. And then I'm going to sub into 2. So I'm going to sub it into this one. Okay, and I'm going to end up with 20 is equal to 2g squared minus, but make sure you put this in a bracket, 8g minus 10. And then I'm just going to move this up slightly so that we can keep going to about there will do. So 20 is equal to 2g minus 8g plus 10, so just tidy it up again. So what you end up is 2g minus 8y plus 10 is equal to 20. Bring the 20 across, so 2g, that's a squared, sorry, 2g squared minus 8y minus 10 is equal to 0. Then what we're going to do is divide everything by 2, because 2 is a common factor. Let's get g squared minus 4y minus 5 is equal to 0. We're now going to try and factorise this. Hopefully it'll factorise so we don't have to use the formula. And you can see here we've got g, and minus 5 plus 1 seems to work. Just double check it. G by g is g squared, minus 5 times plus 1 is minus 5. Minus 5g plus 1g is minus 4g. So we've now got our values for g. So g is equal to 5, or g is equal to minus 1 here. So these are going to be the two different values for my two different circles that were stated in the beginning of this question. So how do we work out the rest of it? Well, we know what our f values are going to be, because we know that f is equal to minus g. So for this one, my f is going to be equal to minus 5. For this one, my f is going to be equal to 1. That comes from up here, because we know that the f is equal to whatever the g is, but the negative version of that. And the only other thing now that we have to work out is c. And once we've got all of them, we can stick them into the equation of the circle. we're told here that C is equal to 8G minus 10. Okay, so for the first one, 8G is 40. 40 minus 10 is 30. So the C for this one is equal to 30. I'm going to do exactly the same for this one over here now. So 8 by G. So this is 8 by minus 1. So that's minus 8. And minus 8 minus 10 gives you minus 18. So this C is going to be equal to minus 18. So once you've got the first one, i.e. the G or the F, the rest of it's quite straightforward. So we have an equation of a circle with those, or we have an equation of the circle with the right hand that I've boxed there. Not quite finished because we do have to write it out as the general equation of the circle. So I'm just going to come to the left here and I'll do it in blue. So we've got the general equation of the circle, remember, is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So the first one, first circle, which is the first box, we've got x squared plus y squared plus 2 times g, so that's plus 10x, and then we've got minus 10y, and we've got plus 30 is equal to 0. So that's that box there done. And the second one is x squared plus y squared, and what we have here is plus, sorry, it's not, it's minus 2x, and then we've got plus 2y, and we have minus 18 is equal to 0. There's quite a lot of elements in this, lads. There's a fair bit of maths, but notice with a lot of these circle questions, you are going to get 3 equations in terms of G's, F's and C's, and then what you're going to do is you're going to solve them simultaneously. So if you're not getting 3 equations, you probably missed something, okay?